look at the area of some common polygons. Okay, now we're very familiar with the rectangle, and usually we look at this area is our length times our width. Most of us are fairly used to that. Okay, now a parallelogram. If I look at the length times the width, that doesn't really work. But if I draw in this, which I'm going to call height, notice now I have here a rectangle. Okay? If I flip these ends right here in, then they would fold in on each other. And this area here plus this area here, these are triangles, 1/2 the base times the height. Okay? We would get a full triangle, right? So, because remember, or we're fixing to talk about, area of a triangle is 1/2 its base times its height. So actually we would get 2 of those. So 1/2 of 2 is just 1. We would get the base times its height. Well, if we add that to this, what happens is we overall get what is considered in a parallelogram just the entire base times the height. Because we're adding the square and the 2 triangles together, or I'm sorry, the rectangle and the 2 triangles, which basically becomes 2 rectangles put together, giving us the entire base times that height. Now I've already mentioned the triangle, because a triangle is half of a rectangle. If I look here, this makes 2 triangles, so that's half of a rectangle. And so that's why in a triangle, we always take 1/2, and we always have to have a right angle with it. And that's why I don't take the length of this side or this side. I take what is considered the height times its base, so 1/2 the base times the height. Now a kite isn't necessarily a square or a rectangle or a parallelogram. So we have to draw these diagonals. And one of the diagonals, the one that goes from here to here, is going to be called D1. Basically the distance from tip to tip. This one is going to be called D2. And if you think about it, normally in our area of, say, just a regular rectangle, we take length times width. So we're going to take D1 times our D2. But since we don't really have a rectangle, we're going to take 1/2 of it. And the reason why is because you'll notice that we don't have an exact rectangle. We can make a rectangle, and then we're cutting off these right angles here. And so that's why we only take 1/2 of it. Now a trapezoid, it has these 2 angles here. And so again, we create a right angle, which creates our height. So this creates a triangle for us. And so we look at 1/2 of the height times our B1 plus our B2. So we add our bases here. So in a trapezoid, think of your T and we add a T. We have a T here, okay? That's one way to kind of look at it with the trapezoid. Now, a regular polygon, it doesn't matter, like this one is a hexagon, it's got 6 sides, okay? One thing that we have to do is we find this height. That height is called the apothem. It creates that right angle there. That is our A. The length here, and notice it says regular, meaning that each of these are the same length. That's our S, length of the side, okay? So basically this is going to form a triangle. So we have our base times our height to get this area. So we have 1/2 the apothem times the base, or the S, and we have, in this case, 6 of them. But for any regular polygon, we're just going to say times n. N is equal to the number of sides. However many sides we have. That's going to be however many we look at. Okay? So we've got a couple of others, and these are the circles. Now, the area of a circle, remember before we've talked about the radius and the diameter of a circle. And so this is our radius from the center to the outside. The area of this, meaning, again, the area is always how much is inside of here, okay? So it's all the value, all the space inside there. It is going to be pi times the radius squared. Now the area of a sector of a circle, which is strictly this part, okay? We're not looking at the entire circle, we're just looking at this little bitty part. We have this angle theta. And so remember that this all equals 360. So we're going to take theta divided by 360, basically to find out how much of the circle it is. Well, however much of the circle it is means however much of the entire area it is. So we're going to take theta divided by 360 and multiply that by the entire area of the circle. So this is like having fraction of the circle, what proportion, what percentage, that type of thing of the circle it is, and then multiplying it by the area of the circle. So I want you to try to find some of the areas now.